Welcome to this video on how to use significant figures or sig figs in calculations. Again, this is part of a two-part series of videos on sig figs. The first one was about counting sig figs and reporting them. So if you haven't watched that one, go watch this first before coming back to this video. So when we do calculations with sig figs, we really have one overarching rule. And that rule is really simple. You're limited by your least precise measurement in the lab. Makes sense, right? Your least precise tool should be the one that holds your calculations for reporting. From there, it's all about the calculation you did to get to that place. And so recall your order of operations, right? Parentheses, exponents, multiplication, division, addition, subtraction. I want you to know that multiplication and division have one set of rules. Addition and subtraction have another set of rules. Parentheses and exponents are just going to be part of resolving mixed operations. So let's start with multiplication and division. With multiplication and division, the sig fig rule is very simple. Take the fewest sig figs for your answer. So whichever value in your calculation has the fewest sig figs, that's going to limit you. Now, this is all assuming that we've sort of screened out all the conversion factors and the counting numbers that have infinite sig figs and can be ignored. Go back to the first video to review those. All the examples that we see here are just going to have those values screened out. So let's imagine that we're multiplying 4.5 meters times 0.03060 meters times 0.391 meters. You could imagine doing this, say you took three different measurements of an object's length, width, and height, and maybe you are now calculating, right? So if I look at my units, the units would also multiply. So my answer would be in meters cubed. By the way, there's quite a bit that comes out of the calculator with this. If I just punch in 4.5 times 0.03060 times 0.391, I get 0.0538407 meters cubed. If I report this, I look foolish. It looks like I don't know what to do with my measurements because none of my tools have that many decimal places in them. So I think back to my sig fig rules and I say, oh, this one has 2 sig figs. This one has 4 sig figs, right? These ones don't count, but these ones do. And this one has 3 sig figs. This 0 doesn't count, but these last 3 numbers do. And multiplication and division say fewest sig figs. So what do? I cut my answer at 2. So I look at this answer and I say, oh, the zeros don't count until something non-zero comes along. So those are out. So I would keep this one and this one. And by the way, I do round. So I look at 3 and then I look at the 8 after it and I would report 0.054 meters cubed. Now I have an answer that's both mathematically correct in units, and correct in terms of the number of significant figures. I'm being honest and not foolish about my measurements and my calculations. I'm going to give you an example which you can pause and then do and check up on. Here's my example. 453 centimeters divided by 2.031 centimeters. Do this calculation, play with the sig figs, make sure that you report an answer with the appropriate number of sig figs and units. Pause the video, give it a try, and see what comes up. The correct way to report this would be 223. There'd be no units. Why? Because I have centimeters divided by centimeters. 223 because I'm limited by this number with 300 significant figures in it. Let's check out the next rule. Recall that multiplication and division was all about the fewest sig figs, so you counted the sig figs and you were limited by your least. Addition and subtraction is about a different thing. It's about the fewest decimal places. And so the easiest way to see what's going on here is to really write out a math problem in terms of the way you used to with elementary school, for example, right? 432 nanometers, and I'm going to put the units off to the side just so it's a little easier to keep track of, plus 7.3 nanometers minus 28.523 nanometers. The first thing I want to look at when I do addition and subtraction, all of these units had better be the same, otherwise I'm going to need to convert before I can do anything. But I'm lining them all up, and I'm looking at this, and I'm seeing that my least precise number ends at the ones place. So my answer ends at the ones place. So even though the calculator gives me 410.777 and units, nanometers, right? I can only add and subtract things that have the same units. I'm going to report 411 nanometers. This is how I'm honest with myself. This is my least precise measuring tool, and so I cut off here. Again, I'm going to give you another example. Think about things that you need to do converting wise, lining up wise, etc., and give it a try. Pause the video. You're going to take 43.7 decimeters minus 2.341 centimeters. Pause it, see if you can solve it and get the same solution that I do. I hope you got 43.5 decimeters. Notice that, and I wrote this incorrectly at the beginning of the problem, we had decimeters and centimeters, so I had better convert them before I can work with them. There's 10 centimeters in a decimeter. And so, based on the same thing as before, 43.5 decimeters. Let's see what happens when we mix operations. So when I have multiplication and division and addition and subtraction in the same problem, I better follow the rules for the order of operations. Remember, resolve parentheses and then exponents and then multiplication, division, addition, subtraction, right? Start here and work your way to subtraction. The other very, very, very important thing, round at the end only. Do not round in the middle. You'll have problems otherwise. But kind of keep track with the sig figs as you go. Don't round, but remind yourself where they end. So here's an example. 78.2 grams minus 44.889 grams divided by 0.0087 centimeters cubed. I notice that it's okay to subtract grams, and I also notice that I'm going to end up with grams per centimeter cubed as my units. Let's just go ahead and grab that. The calculator tells me that it's 3828.85057471 grams per centimeter cubed. But my knowledge of sig figs tells me that I better compare. I know that this has 2 sig figs, and I know that I'm going to resolve the parentheses first. So when I look at this, my real answer when I finished over here was 33.311 grams, and I noticed that it has to end at the 10th place, right, based on the rules that we just talked about. So this really has 3 sig figs mentally. So I better stop my answer at 2 sig figs. So what I'm really going to write and what I'm really going to report is 3.8 times 10 to the 3rd grams per centimeter cubed. Why? Because I mentally took care of sig figs in my parentheses first, and I kind of made a mental note that there were 3 in that number because I was going to divide by a number with 2, and so my final answer also needs 2 sig figs. Let's try one more example on your own and see if you come up with the same answer or not. 568.299 grams per milliliter minus 232.1 grams divided by 5.3 milliliters. Pay close attention to the order of operations and also close attention to the units and whether you're allowed to add and subtract those things. And so here's another look at that problem, just written a little bit differently to show where the division is. And the most important thing to recognize at first is that the division gets done first, and you're keeping track in your head that after using the right sig fig rules on division, there's 2 there. So I write it into my addition and subtraction problem that comes second, and I notice that if I keep track of that second sig fig, and I do that with a thick line, that my problem ends at the ones place. And so when I do my subtraction, I get 525 plus a really long, ridiculous string of decimals, and so I cut it off at 525 grams per milliliter. I round down because that was a 0.1. So that's how you use sig figs in calculations. And in your labs, especially when you make these measurements and do calculations with them, it's really important that you use the sig fig rules correctly so that you can be honest and precise about the measurements that you made.